All right, we're going to go ahead and take a look at answers from your practice test. So what we're going to do is look over each question individually, give you an explanation. If you don't have questions on that particular problem, fine, just sit tight. We'll probably get to one that you did have a question on. These first few are fairly easy, so I'm going to work through them kind of quickly. After that, some of them might take a little more time. So let's get started. Number one, which line test can be used to determine if a graph represents a function? If you've been paying any attention at all, it should be obvious. It was the vertical line test. No more explanation needed. All right, number two, which chart is a function? So again, remember, one domain with exactly one range. So take a look. Notice I've got a -1 here, -1 there. Remember, that's not so much the issue, is the fact that you've got this -4 and +3. So number one's out. In this case, notice again, you've got that -1 situation matching up with two different numbers, in this case 2 and 1. In the case of number 3, you've got 0 and 0, but notice those two inputs match up with 3 and 0. That's your problem. In this case, notice each domain matches up with just one range value, so 4 is what you want. All right, number 3, which graph is a function? Well, again, if you use your vertical line test, it's pretty obvious. If we look at A, notice there's 2 points through the same vertical line, not a function. For B, 2 points through the same vertical line, not a function. If we look at D, once again, 2 points here and 2 points there. So it doesn't follow the vertical line test in 2 spots. Definitely not a function. Notice in this case, when I draw a vertical line, it only crosses 1 point at a time. So that's the function we want. Moving on. Let's take a look at number 4 again. Which relation is a function? So again, we're looking at domain and range values. Remember, your domain is the first number, range is the second number. In the case of number 1, notice, or excuse me, part A, number 1 appears twice. That's not the issue. It's the fact that it matches up with a 4 and a 0. So A is out. With B, notice in this case that your 1s again, this time match up with a 7 and a 6. So since 1 has 2 different outputs, not a function. In the case of C, notice each one of these is a 5, so the same input with 1, 2, 3, 4, 5 different outputs. Not a function. D is the only one that works. Notice 1 always matches with 4, 2 always matches with 4, 3 always matches with 4, 4 with 4, 5 with 4. That's fine. Each input with just one output. So D is our function. All right, number 5, which one represents a function? So again, your vertical line test. Notice with A, vertical line touches in 2 spots, not a function. With B, we can draw a vertical line, touches our graph in 2 spots, not a function. C, same story. In this case, you can touch 3 different points, so definitely not a function. Notice with D, we can draw a vertical line at any spot along the graph and only touch in 1 spot. That's our function. So again, these first few have been relatively easy. Let's move on to comparing functions. This is where things become a little bit more difficult, but again, shouldn't be too bad. So notice it asks which relation is linear. In other words, does it form a line? Well, let's look here. Number 1, this isn't even a relation. We're not seeing something equaling something else. So that's out. Notice in this case, we've got x to the 2nd power. If you remember what we've talked about with linear versus nonlinear situations, x to the 2nd power is quadratic. Remember, it forms this kind of U shape, a parabola. So definitely not linear. Now, the choice is between C and D. Now, you have options. Notice that each input matches up with 1 output. So that means it is a function, but is it a linear function? So if you're not sure, and notice for D here, you do have a grid. Let's graph it real quick. So -3, -5 goes there. -2, -1 goes here. -1, 3, and 0, 7. Well, if we try and draw a straight line through those points, we can do it. So it's linear. Now, let's look at the actual graph that's on for part D, see what we've got. Notice it is a function. Okay, I can draw that vertical line anywhere on the graph and still only touch in 1 spot. But here's the problem. In order for a graph to be linear, it has to be continuous, one continual line. And notice we have a break here. So while this is a function, it's not linear. So we don't want this one. C is our option. When we graph the points, They did form that nice straight line. All right, let's move on. Number 7. All right, well, let's read this one and see which of these options makes the most sense. It says, Alicia is saving for a new bike. She started with $100 and is saving the same amount each week. Each equation below describes a situation like Alicia's. In the equations, W represents the number of weeks, and M is the final amount of money that she has. And which of these answers is the rate of the savings the greatest? So notice, we've got multiple things going on here. Notice we aren't told how much she's saving each week, so that's sort of a question. Now remember, we're talking about a linear situation. So y equals mx plus b. So let's start constructing our function by what we have. We know that y equals some number times x plus b. Well, remember, b is what we start with. And notice it even says she started with $100. So in our equation, we should have something plus 100. Well, let's look. A matches that. B matches that. Now notice, here's the problem. For C, it says 100 less than. That's a subtraction issue. We don't want that. Now notice this says M equals the sum of 100 in the product of W and 2. So again, where M is representing our money, so we could actually take this Y out, put M in its place, and instead of our X, we could plug in weeks. So let's look at D. M equals the sum of 100 and the product of 2W. So one option is this 2W equation. Okay? Let's look up in B. In this case, we have M equals 30W. Oh, there's my 0, plus 100. And then in yet another option, we have M equals 100 plus 50W. So all three of these could represent the situation. But here's what the question asks. In which answer is the rate the greatest? And remember, our slope is what's connected to x. So we've got an option for 2, a 30, and a 50. So which one of those is greater? Well, clearly the 50 is. So while B and D could describe the situation, they don't have the greatest rate. A is the one that has that plus 100 and the greatest rate, in this case being 50. So A is what you want. All right, well, let's take a look at number 8 then. Since we have 4 linear functions represented below, which one has the greatest slope? Well, notice A is the only one that actually gives you the slope up front of 5 over 11. So we actually need to figure out, well, what are the other slopes of these lines to be able to answer the question. So let's make ourselves some space here, and we'll see which of these has the greater slope. Let's start with B. Notice it's not in slope-intercept form, so we're going to have to change it up. So 3x subtract 7y equals 21. We want to get the y by itself. So the first thing I've got to get rid of is my 3x. So I'll subtract 3x on both sides of the equal sign. 3x minus 3x is 0. That just leaves me with this negative 7y. Notice I can't take 3x from 21. They're not like terms. So negative 3x plus our 21. Well, we're almost there. Let's keep going. We'll need to divide in this case because notice the negative 7 and the y are multiplying. So we'll divide. That means we have to divide everything by this negative 7. So y equals 3 over 7. Notice negative by negative is positive. So 3 over 7 times x plus 3. So my slope in this case is 3/7. So we'll compare those here in just a little bit. Let's figure out our other slopes. Now, take a look at C. All we've got are coordinates. Okay? We don't know what the slope is just by looking at it, so we'll have to compute it. Remember, slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's pick 2 points. For C, I would pick the first and the last point. For no other reason than they've got those zeros, and that's going to make life a lot easier for me. So if we work this out, if I take negative 4, subtract 0, over 0, subtract 10, well, let's see what we get. In the first case, we'll get a negative 4. in the bottom a negative 10. Well, negative over negative is positive, so 4 over 10. And 4 over 10 can be simplified, divide both of these by 2, to 2/5. Cool. So we only got one more to go. Now, in this case, and let me erase some here to give ourselves some room, for D, notice there really aren't 2 points that are going to be easier to work with than others. All 3 points have at least one negative, no zeros to be found. So in this case, I'm just going to take the first 2 points and use them. So again, same formula. So I'll take negative 8, subtract 4, over 22, subtract negative 11, which is the same as adding a positive 11. So let's see, I'm sorry, I got interrupted there, so let's see what we were doing. Finding our slope here for part D. So I've got everything set up, and remember, subtracting the negative, same as adding the positive here. So let's see what this is. Negative 4 added to a negative 8 is negative 12. And then 22 added to 11 is 33. So negative 12 over 33. So we need to go through and see which one has the greatest slope. So we can do this a lot of different ways. We could find common denominators for 11, 7, 5, and 33, which is not going to be fun, and then convert them all and see which one that would be. An easier method would be, since you will have a calculator on your test for a situation like this, just do your division. So in this case, 5 divided by 11, because remember, fractions can be viewed as division. In this case, as a decimal, is decimal 4, 5 repeating. It's just 45, 45, 45. So 45 hundredths repeated. 3 over 7 turns out to be about 42 hundredths. Actually 43 if you round it up. So about 43 hundredths. And I guess I shouldn't say equals. I should say approximately 43 hundredths. If we look at 2/5, 2/5 turns out to be 40% exactly, or 4/10. And then if you take 12 and divide it by 33, remember with slope, it really doesn't matter if it's positive or negative. In this case, it would be approximately a negative 36 hundredths. So it's very easy to see now that they're in a decimal format that A is what we want. 5 over 11 is the greater slope than any of these others. And again, remember with a negative situation, how steep the slope is just direction. But in this case, 45 hundredths is still greater, even absolute value-wise, than negative 36. So A is what you want. All right, moving on. Constructing functions. Let's take a look here. Number 9. A valve on a water tank is opened and it drains the water at a rate of 35 gallons per minute. That's important. After 12 minutes, the valve is closed and 350 gallons of water remain in the tank. How much water was in the tank before the valve was opened? So let's think about our equation. This is going to be a linear situation, so y equals mx plus b. Okay? Remember, m being your slope, b being your intercept. So let's review the question. It says the valve on a tank is opened and drains the water at a rate. So my rate of change is 35 gallons per minute. So I can take my m out and put 35 in its place. Now it says after 12 minutes, the valve is closed and 350 gallons of water now remain. Now let's think about this 35. Should it be positive or negative? Because notice it says this is how much remains, which would make you think that, hey, there's more water in there to start with, which would make sense. So this 35 should be a negative 35, because we're losing water over the course of time. So negative 35x plus b. Well, problem is, our question is, how much water was in the tank? In other words, what was your starting point, your slope? Or excuse me, not your slope, but your intercept. Well, we're not told that. So let's try and figure that out. Well, remember, we said that after 12 minutes, the valve is closed and this much remains. So we could say that y represents our number of gallons, x represents our number of minutes. So let's use our information and plug it in. So I don't know my starting point, so b remains. I do know that I have 35 gallons lost per minute, and in this case, I know 12 minutes passed, so times 12. I know that after all of that is said and done, I'll have 350 50 gallons less. So let's work this out and solve for B. Well, I know that negative 35 times 12 is a negative 420, plus our unknown B should equal 350. Well, now that I'm at this point, it's a one-step equation. I'll simply add 420 to both sides to get B by itself. And when we do that, we get our 770 gallons, if I can write today. So that's why D is the choice you ultimately want. We can use our equation to figure out that number of gallons lost. Now, you could do a trial and error kind of thing, but using your equation is going to get you there a little bit quicker. All right, let's take a look at number 10. During the weekends, Nick babysits 2 children who live next door. Each time he babysits, Nick earns $5 per hour, along with an $8 tip. Which function models the relationship between how many hours, H, Nick babysits, and his total earnings, T of H? Now, remember, we've seen formats like this where we've had things like f of x. And remember, we said that's just another way of writing y. So we can think of T of H as just another way of writing y. And our H is standing in for x, just to give you an idea of some of the terminology we've been using. So let's go back and look at our problem. We know, again, that for a linear situation, y equals mx plus b. And let's substitute some things. We said for our y, we're using T of H. So let's substitute that. And we said instead of our x, we were going to use h. So we need to figure out the rate and the starting amount. Well, let's look back at the problem. It says that Nick will earn $5 per hour. That is a rate. So 5h. And then it says he's going to get this $8 tip, which assumes that he's going to get $8 regardless of the time. So you could almost say that as soon as he walks through the door, he's automatically got $8 in the bank. So that's our starting point. He'll begin with $8 already his. Well, let's look. A doesn't make any sense because of that subtraction sign. It's out. If we look at B, clearly it matches what we have here. C doesn't work. Notice we're not going to add the 5 and the 8 and then multiply. That doesn't make sense. Nor are we going to add the number of hours to 8. That doesn't make sense either. B is the only option that would work. All right, let's take a look at number 11. This table shows the cost of various pizza slices at JC's Pizzeria. So 3 slices cost this much and so on and so forth. Which function can be used to find the cost for X number of slices of pizza? So again, y equals mx plus b. So we need to find the slope. We need to find the intercept, the starting point. Well, let's look at each of these. Notice, here are the slopes given. Here are the intercepts. Notice we're not given any of that information up front, so we're going to have to do some calculation. Let's start with slope. All we need are 2 points to calculate slope, so let's do that. And since none of these numbers are necessarily easy to work with, I'm just going to pick the first 2. So again, number of slices is x. Our cost is y. Okay? Notice we were told that x is number of slices. That's how I made that determination. So let's get started. 770 subtract 380. Goodness, that would have been a real mistake. Over 6 subtract 3. Cool. So again, you will have a calculator on the test. So 770 subtract your 380 gives you $3.90. 6 subtract 3, of course, we all know as 3. Well, notice we can do some simplifying here. 390 is divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And we'll keep our decimal point in the same spot. So notice our slope, y equals 130x plus. Now we just need to find the intercept. Let's hold up a minute. We just found the slope. Notice each of these has a different slope. 140 clearly doesn't match. 120 doesn't match. $1 doesn't match. You don't even have to find the intercept, boys and girls. We know it has to be B because it has the slope we want. So in some of these problems, you don't even have to work it all the way out. If you get part of it, sometimes we can match it up. And in the case of number 11, that's exactly what we can do. All right, moving on. Number 12, take a look. The school dance committee wants to earn money for the 8th grade trip. The cost of a ticket for the dance includes $5 for refreshments and $2.50 for the entertainment. If the DJ's cost is $120 for the night and decorations cost half the price of the DJ, which equation represents the amount of money the dance committee earns, Y, based on the number of students who purchase tickets, X? Holy cow, that's a lot of information. Well, let's break it down. First, we know that the cost per ticket to the dance includes $5 for refreshments, $2.50 for entertainment. So those are important pieces of information. Okay? We also want to know the DJ's cost, $120 for the night, and the decorations cost half the price of the DJ. Now, we want to figure out which equation represents the amount of money earned. Okay? Actually, I'm going to highlight that because that's the key word pretty much in this whole problem, earn. So, let's break some of this down. Let's first look at tickets. Notice we weren't told what the ticket price would actually be. We just said the cost of a ticket includes $5 for the refreshments and $2.50 for entertainment. So if I add those together, I can figure out the cost per ticket. Well, if we add those together real quick, we can see that that's $7.50. Now think about that. $7.50 per ticket. That's a rate. So if we're looking at y equals mx plus b, where here's our slope, our rate, then we're going to take the m out and put 750 in its place. Well, let's look. A has a slope of 5. B has a slope of 5. We don't have slopes of 5. We have a slope of 750. So that leaves C or D as our only option. Well, now we need to figure out the intercept, because notice the intercepts are different here. The slopes are the same. So at this point, you got a 50-50 shot of guessing right. Let's continue. We've got to figure out that intercept. So let's look. It says the cost for the DJ is $120. So let's write that down. $120, and I'm going to write just beside it here DJ so that I know what that is. And then it says that the decorations cost half that price. Well, half of 120 is 60. All right, and these are decorations. So I'm just going to write DEC beside that to represent those. Now, here's the deal. Should this be a positive or negative amount? Sorry, I got interrupted again. So we're trying to figure out this 120 and this 60, how we should count them. Okay? Should they be positive values or negative values? Okay? Now notice that key word that we highlighted, earns. They're going to have to pay the DJ. They're going to have to pay for these decorations. So in our equation here, it shouldn't be plus B. It should be subtract B, or we could write it as adding a negative B. So these values are both negative. They've got to pay that before they can start earning money. So if we add these two negative values together, we'll get a negative $180. So this is what the equation should look like. $7.50 per ticket plus the $180 they've got to pay up front for the DJ and the decorations. C is the only option that works. Notice D only accounts for the DJ, not for the decorations. A big problem. All right, let's take a look at number 13. The graph shows how much money Ms. Sullivan had in her art supply account, represented by X number of weeks after the start of the school year. So again, X is representing number of weeks. Y then would represent the amount of dollars, okay, that art supply budget. So, question, what does the y-intercept of the graph represent in our situation? Well, let's find it. We're at 0, looks like 300. So let's write that down. The point 0, 300. Now, remember, X represents number of weeks. So we could say at 0 weeks, she has 300 what? Well, again, this is measuring money, so $300. So let's read these and see what it says. She spent $50 per week. Well, that has nothing to do with this y-intercept, so A's out. B, She spent all of the money in 6 weeks. Well, that may be true, that may be not true, but ultimately we're trying to figure out what the y-intercept means. Y-intercept has nothing to do with when she spent the money. That's out. C, she had $200 at the start of the school year. Well, let's look. $200, not even on the graph. That's out. D, she had $300 at the start of the school year, which is what this means. At 0 weeks, so school hasn't started yet, there are $300 there. That's the one we want. All right, moving on. Qualitative graphs. These are the ones that I'm hoping you guys feel pretty strong about. So let's take a look at a few. Number 14, Alex measured the height of the birthday candle and then lit it. Every 30 seconds, she blew it out. She measured the new height, then lit the candle again. She graphed the results. Which function models her data? Well, let's think about it. You've got a birthday candle. You light it. Blow it out, measure. Light it, blow it out, measure. Well, let's think about it. A, is the height of the birthday candle going to increase? Not any birthday candle I've seen. That takes out B as well. Birthday candle's not going to get greater over time. So it's either C or D. Now think about it. You got a birthday candle. You light it. Does it stay one height and then, as it's getting shorter, notice it's a curve here for C, gets shorter faster and faster and faster and faster? Or, when you light it, does it gradually get smaller, 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 and go out? Well, I don't know about you, the birthday candles I've seen tend to get gradually smaller and smaller before they finally go out. So, D is ultimately what you want. Again, C, not necessarily a bad answer, but again, a birthday candle isn't going to suddenly pick up speed as it's burning. Okay, it's just not going to happen. Let's take a look at 15. A car is driving at a steady speed on a highway. It then slows down when it gets to a town and then continues at a slower, steady speed. Which graph shows the speed of the car as it changes over time? Well, let's read each of these in our situation. It says first, the car is driving at a steady speed. Well, let's start there. A, starting out at a steady speed. Notice the speed doesn't go up or down over time. So A is a possibility. B, notice the speed is increasing over time. That's not how our situation starts off. So B's out. Let's look at C. That nice steady speed to start out with. So C is an option. For D, speed's heading down. Well, that's not what we said was happening. We're not slowing down immediately. So that's out. Left with two choices. Then it says it slows down when it gets to a town. Well, notice both of these show the speed decreasing. However, this is the key. It then continues at a slower, steady speed. Well, A does have it slowing down, but it actually has it slowing all the way to a stop. And that's not what happens in our situation. It slows down and then continues at that slower speed. So C is what we want. A only matches the situation so far. All right. Look at 16. Which table is consistent with the graph? So notice we've got length along one side, weight along the other, and we've got to see which one of these matches up. Well, let's look first at what the x's and y's represent and see if we can't eliminate a table that way. Well, notice this says length in centimeters for your x, length in centimeters, length in centimeters, length in centimeters. Weight in grams, weight in grams, weight in grams, weight in grams, weight in grams. So that's not going to work. So here's what we can do. We can start plotting points and seeing, hey, which of these seems to match the situation? Well, notice all of them start off with a 6 except for D. So let's see where things are at 6 and see if that helps us. So at 6 centimeters, we're about here on our weight. Well, notice that's the 10-gram line. That would mean this is 5 grams, so it's just short of 5. Well, 4 seems like a pretty good estimate to me. So 6 and 4, 6 and 4. Now notice this says 6 and 6. That one point's off, it throws the whole graph off. Notice this then says at 4, you're going to be at 6. Well, at 4, you're not even at 5 yet, so this one's out. So again, we're using the table to plot what we've got. Well, let's look next. Both of them have a 9, so let's plot it at 9. So here's 10, back 1. So we'll go up to the graph, put a mark. Notice this is the 10 line on weight, and it's just below that. So let's see what we've got. This says at 9 centimeters, they're at 9 grams. Well, that seems to match. 9 centimeters, 12 grams. Well, notice 12 would probably be somewhere up here. Doesn't match the graph. So by plotting just 2 points, I can see which table works. In this case, A is the one we want. All right, moving on. Number 17. Jackson is going to Cleveland during the winter. Why you'd go to Cleveland in the winter is beyond me. As he begins driving, the car begins to warm. Jackson stops for gas and continues on his trip until he reaches Cleveland. He then turns off the ignition. Which graph shows the temperature of the car during the trip? Well, notice we've got temperature on each y-axis over time. So let's think about it. As he begins driving, the car begins to warm up. Well, notice all of the graphs show the car warming up. So that really doesn't help us. But here's the key. It says that Jackson stops for gas. Now let's think about it. If your car's on, it's hot. If you stop it, it starts to cool down. Well, let's look at these. For A, the temperature increases, and then stays relatively steady. Well, if he stopped for gas, the car's temperature is actually going to drop. Okay? A doesn't show that. Well, let's look at B. Goes up, goes up, goes up, stops for gas, temperature starts to go down. So that seems to fit. For C, temperature goes up, stops for gas, temperature falls. Seems to match. D, temperature goes up, stops for gas, starts to go down, seems to match. Let's read on. It then says he continues on his trip. Well, let's think about it. If he continues, that means he's going to start the car up again. The car should warm up. Well, notice in C, it never does warm back up again. For D, it actually just goes straight down. In this case, the temperature dips when he stops, comes back up when he starts the car again, and notice it says he continues on the trip till he reaches Cleveland. Once you get a car up to speed and tend to maintain that speed, your car will reach a temperature that it'll maintain. And then it says once he gets to Cleveland, he turns the ignition off. That's when the temperature should go back down. So B is the one we want. Moving on. 18, thank goodness, last 2 problems. And I'm sure you're tired of hearing my voice by now, but again, I want to go over all of these so that way you're ready on Friday. So number 18, this graph shows the distances Adam, Barry, Casey, and Drew drove along the same highway at the same time. So again, we've got a graph for Adam, for Barry, for Casey, and for Drew. Which statement correctly compares the functions in terms of their rates of change? Now remember, rate of change is another word for slope. So let's read them. That Adam drove faster than the other drivers. Well, yeah, greater rate of change. Notice he went a further distance over the same period of time. That means he was driving faster. Notice, did Barry drive faster than Adam? Well, clearly not. Did Casey drive faster than Barry? Well, no. Did Drew drive faster than anyone? Well, definitely not. So A is the only one that even remotely makes sense. Pretty easy problem. All right, last one. Let's look at 19. Amelia took a pitcher of milk out of the refrigerator on a warm day. Which is the most reasonable graph of the temperature of the milk over time? Now, we dealt with a situation very similar to this. Our only difference was we started with hot chocolate and took it out and left it. Well, let's see what would happen to milk. Milk starts off cold and then gets warmer. Well, let's look at our options. Number 1, we got B here. It's a line plot. We haven't even discussed line plots this year. It's out. D, a bar graph. Once again, we haven't even discussed bar graphs this year, so that's totally out. That leaves us with A and C. Well, notice, A is one of those kind of stair-step situations. Now, let me ask you, have you ever been outside, warm day, you've got a cold beverage, and suddenly noticed that the temperature was the same and then suddenly got warmer? Stayed the same, suddenly got warmer, stayed the same, suddenly got warmer? It doesn't happen that way. When you've got that cool beverage, it gradually warms up until it reaches the outdoor temperature, and then it'll start to stay consistent with whatever the outdoor temperature is. So C is the only option that works. Guys and gals, I hope this practice test has been helpful. I hope this explanation has been helpful. I do apologize for the length of time, but again, I want you to be ready for tomorrow. I want you to score well on this test. Remember, it is the last test before the quarter ends. I want you to do well. Ultimately, we'll have our corrections and retake due either Wednesday or Thursday of next week. I'm guessing it'll be more like Thursday. So, good luck to you. Take this home. Those questions that you didn't understand or are still working on, please do continue. Use all the classwork assignments and homeworks that you've been given, quizzes, those kinds of things. Study, study, study. Want you to do well. Good luck.